Hello everyone, welcome back to your channel QERT. So after a long time, I am preparing a video. So recently, I have learned that many people want to learn the optimization technique. So I have decided to prepare a series of videos where I'll discuss around 25 to 30 way to do the optimization in Spark, and that will be very much beneficiary for everyone. So I request you all to follow along with this video and the series of video which will coming after this video, and let's start today's journey. So today we are, as you can see, we are going to start about Spark optimization techniques, which will help you to complete your job faster. And when you will complete your job fast, that's mean you will use less resources. And when you will use less resources, that mean less cost. So yeah. Before starting the video, I'd like to again introduce myself and why I am the right person to teach you this. So, my name is Ganesh Ghosh. I have completed my master's in data science. Also, I have completed my MBA in operation management. I am a certified Spark professional. I have completed my certification from Databricks, the mother company of Spark, and a Spark Databricks certified data engineer also. I have total 9+ years of experience in this field as a data engineer, as a Spark developer. I also have Snowflake Snowflow certification. So if I talk about my experience, I'm very much expert in AWS Snowflake, Databricks, Python, Spark. So yeah, that's all about me. Let's move forward. So today we are going to discuss about broadcast join, how we can efficiently join large and small table. So let's start today's video. Broadcast join. What is broadcast join is basically. In my screen you can see broadcast small data set to all executors. So here we have to understand and remember that how Spark work internally. So suppose here in this screen, if you know the architecture, if you don't know, please check my previous video and you will get the understanding that how executor driver and Spark architecture does work. So here you can see in this video, so we have a driver node and we have three executor node. Okay. Now suppose what basically happen, our data stay in executor, suppose as a partition, our data is there in the executor. Now large data, okay. So broadcast join is suitable when you have one data set which is large and another data set which is small, okay. So that will be, and you need to join in that case, that will be the suitable condition or situation, you could say, to do the broadcast join itself. Why broadcast join? Broadcast join, basically we know very well that Spark any white transformation to the shuffling, and shuffling is a very much costly. It used lots of resource. It will shuffle data between the executors or partisans, you can say. So in this case, what will happen if you do the broadcast? You will just send your small data to every executor. So let me give you an example here, practical life example. Suppose your manager got some task from the higher management, okay. Now under your manager along with you there is two more members, okay. So total three members working under your manager. So every time it got a task, it I mean the manager get the task, you guys go to your manager, ask him that what task you got, give us the information, and come back to your desk and perform the task. Instead of that, what will happen? Whenever your manager will get any task, he will directly send you a mail and all the information regarding that, and you will keep that to yourself. Then whenever you need the details about the task, every time you don't have to go back to your manager and ask him about the details. I mean, that time you can save in that way. And suppose if you are keeping the list of the task to yourself, okay, and whenever you need to perform the task, the information you can just go ahead, it is already in your mail, you can just check. So consider yourself as a executor and driver as your manager. So what will happen in case of broadcast joints, your driver, I mean your manager have the small data sets, that data set that will get broadcast to executor. I mean driver will broadcast those to executor, and in the image you can see the small data set. And then every executor have the same same data set, I mean to themselves. Suppose it is 10 MB, okay, let me mention here that Spark broadcast join can handle equals to less than 10 MB of data, okay. We can change this as per our requirement, but we can modify this, but this is by default 10 MB, okay. So suppose this is a 10 MB file, this is a 10 MB file, and you have large data which is maybe 50 GB of data, okay. So a 50 GB may be divided into three executor in different partitions. You can calculate by default number. If we go by default, it's 120 MB per partition. So how many partition will be 50 GB data, you can calculate by yourself, and that many partition divided by 3. So every executor will have the same number of partition, maybe uh, again maybe, okay, just take a hypothetical situation here. So every executor suppose have the same number of partitions for the large data set, and now you are broadcasting that small data set which is less than equals to 10 MB to every executor, just keeping it to themselves. Whenever they will need it, they for joining purpose they will use this. If they don't need it, they will not use it, okay. But we are doing broadcast join, so definitely they are going to use this data. So yeah, let's move forward. When to use it, I have already discussed use for small large dataset join only. Remember, this is a very vital point. You will not always uh, use the broadcast join. We have submerge join, that is for big data sets. But if you have a small data set or another one is the large data set, in that case you can do the broadcast join very easily, and that is the actually suitable condition to do the broadcast join. Why you should not do when you are using large data set, joining with large data set. Suppose you already have a large data set, you cannot, I mean you should not actually broadcast a large data set to every executor, right? I mean that will consume lots of memory. So yeah, there is few other reason, but yeah, this is the suitable condition. Best use case is, suppose you have a small dimension table joined with large fact table. Suppose for example you have the sales data, okay, I mean fact table for sales, okay. In that case and another table is for product, okay, where you have, that is your dimension table, product table, where you have the product details. So if you want to join those two tables between themselves, that case you can use this broadcast join. So yeah, okay, everyone, here I have prepared a small example for yourself, how you will do the broadcast join. But first, before doing that, let's understand the whatever I was talking about till now. So here you can see we have two tables. One is large table, another is small table. Okay, large table, here you can consider sales table, which is you can consider as the fact table, and another table, that is the small table, you can consider it as the dimension table, okay. So Now you have two tables. So for example purpose only to help you understand, I kept only 20 and 5 records here in the team table. Uh, but otherwise it can fact table or the large table can have terabytes of data. Okay, but a small table should have by default less than equals to 10 MB. Okay, yeah, of course you have the option to increase this, but this is the ideal situation. Okay, now we have sales table where we have order ID, we have product ID, we have quantity. Okay, and in our dimension table we have product ID, we have product name and the price. Okay, let's join both the table. Okay, uh, so here we have a common factor. We know we need a common column to do the joining. So here we have product ID. Based on this we'll do the join, but before that we have to create the table. We'll use in this case Databricks, which I am certified, and let's use that and see how it will happen. So I have already wrote the code here to create the table. Here we have the sales data and we have the columns as I have shown you already in the Excel: order ID, product ID, and quantity. So this will create basically this table, the large data sets table. And here we have another product data where we have product ID again and the course name and the price, product ID, product name, and the price. So this will create the dimension table which is required. Okay, let's do it one by one. So I'm first creating the sales table. Or you can say here that in Spark it is data frame. So I'm creating the sales data frame. After the sales data frame, I'll create the data product data frame. So currently I am creating just the list. I'll convert this. Now I am creating the data frame actually. So I am creating both the data frame, sales data frame and product data frame here. Okay, now we have to keep in our mind that to do the broadcast join we have to import the broadcast function from PySpark.sql.function. Import broadcast. Okay, keep it this in my in mind, because sometimes we forget this and we get the error and we try to find out what error we have done. So here this is the condition to do the join. So basically you can see here the result is our data frame, okay, which we are creating. So we take the sales data frame which has the large data. Okay, we are doing the join, and here you can see broadcast function. We are using the broadcast function to broadcast this product df. This is the small df, small data frame of small table, which is dimension table, you can say. We are broadcasting it to every executor. Okay, and after broadcasting it to every executor, we want based on the product ID which is available in both the table. You can see product ID column we have. So here also based on this it will get join, and it will give us the result of the join. But in this case it will just broadcast this small dimension table to every executor. That is our intention. So let's see the result. Uh-oh. Just a minute, we have changed the name to df. Yes. So here you can see we have joined all the column in this table perfectly by broadcasting the small data set to every executor. It is the one of the best way to do the optimization. There is too many ways to do the Spark optimization. This is one of those. So in our next videos we'll discuss about the about next strategies, how we can do the how we can optimize the Spark job and run our Spark job better way. So keep watching. Thank you so much.